Hey everybody, this is Larry. This is June 27 of the June LeetCode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Loading. Candy. Usually I solve these live, so it's a little bit slow. Just fast forward, and sometimes I even talk about like a daily update of some sort. For example, earlier in the day in the contest, finished third, yay! Try to celebrate victories, so that's why I'm just maybe it sounds like bragging, but if you've been watching the stream or following, I've had a really bad slump where I just couldn't solve problems for some reason during a contest. So it's good to kind of have a good contest under my belt. And then the night in New York anyway, finished 108th, had a lot of silly mistakes, and we're just slow in general. But yeah, I feel like I did okay today. So yeah, it's a decent day. Anyway, so let's get back to today's farm, Candy, in case you're wondering, by the way. If not, well, you're still here, hopefully. So anyway, okay, there's n children standing in line. Each child is assigned a rating. So we rate childs, great, huh? Children? Childs? So we're rating children. Given candies, each child must have one candy. Higher rating must get candy than the neighbors. Okay. Return the minimum number of candies you need to have distributed the candies to the children. Okay, so I think this just becomes a sort of a simulation problem that you can think about as maybe a breadth first search or something like that. But the kind of the first observation is probably just greedy, right? Because thinking backwards, like the problem tells you that the highest rated child has more candy than is left and is right. But in reverse, that means that to minimize the number of candies, that means that the lowest rated child will have one candy because that's the minimum. And then from then on, you could kind of spread it out to kind of see, you can kind of just see how, yeah, the order to process it. I guess that's about it. Is there anything else to say about this one? I don't know. Yeah, I think that's maybe the way I would think about it. Because from then, so basically the idea is that you give the lowest, or you give one candy to, or the fewest. So you sort them in order. You give the fewest to the lowest rating, and then you remove that lowest person, and then you kind of do it again. So you kind of keep doing it. So in Dan and Marian, and you kind of just do the lowest that you can do. And I think that should be good enough. There's going to be a sorting there, so it's n log n, but usually n log n is going to be fast enough unless you're doing some crazy thing within the constants. And in this case, we just use it for sorting, so we do not. So yeah, let's see. So index, let's just say we have assorted ratings. We want to enumerate from here. So then here we have for index rating in here. What are we doing? That means, oh, actually, whoops, I messed this up. We want to sort this thing by rating first and then index. Well, it doesn't really matter if it's after. Huh. Actually, that's interesting. Maybe I didn't. For some reason, I thought that the ratings would be unique. Now I'm trying to think about a second where. What happens if two people have the same rating, right? And I'm just trying to think about this sorting and whether the order matters. And I guess it does not. It does not only because children with a higher rating get more candies than their neighbors, but that does not mean children with the same rating has to have the same candy as his neighbor. That's not one of the requirements. Even though it feels like intuitively that should be the case for fairness or something, but that's not even the case, right? Two people have the same rating doesn't mean anything, because, for example, you can have a child, that's like 1, 5, 1, and then you have maybe like 1, 2, 3, 4, 5, 4, 3, 2, 1. This 5 is going to have way less candy than this 5 because they're forced to have, like the solution supposed to be 1, 2, 1, maybe 1. Let's see. Yeah, 2, 3, 4, 5, 4, 3, 2, 1, something like that, right? Is the answer. But that is, the fives don't matter, but we'll process them together, or not together, but in that order. So okay, so let's say now we sort by the rating and we keep track of the index. We just go left for right for purposes. But then now, so for index, for rating index in this thing, what happens? Now let's also have an answer array, which is let's do -1 times n, where n is the number of ratings. Okay. So then now we just go. Okay. So if rating of the index. Okay, so current. I'm just trying to think about how to phrase it correctly, right? Because we know how to say it in English, but phrasing it to computer, that's the hard part. Talking to computers, they're cuckoo. Okay, so yeah, so let's say we give them default of 1 candy. If the current rating is greater than the neighbor, and of course this assumes that index -1 is greater or less than 0, and this is, then current is equal to max of current and an answer of index -1, right? And of course, this number will never be -1 because we're processing this in order. Also, this is ratings, not rating. I guess we never really use this, but I mean, you could copy and paste. It doesn't really matter. But yeah, but if basically now you're a child, you look to your left. If you have a higher rating than them, then you should have that number of candy plus 1, right? To make sure that you have more than them. And then same thing for looking to the right. And then that's pretty much it. And then we just set it to current. And at the very end, we turn answer. I feel like this should be it. Though oops. And also our earlier case. Let's give it some running love. Ooh, did I miss a parens? Probably. There's so many parens. For rating index and sorted in. I guess technically this is this. It's either that or I need to do a paren over this thing, which is maybe fair. Maybe this is what I need actually. So that it's a tuple properly. Okay. And technically I guess we don't even use the rating, so we can just. No, but we have to sort it by that, so okay. But here we don't use it, so let's just do this. Oh. I know that this isn't the right answer because I look at it and it's clearly wrong. But it's not wrong. It's just that, we want the total, so that's actually my bad. Oops. And you could do it either way. You could either add it while you set this thing, or you can do a sum of here. I think that should be good enough. Oops. So yeah, so the key part about this problem, and I hope I get this right because otherwise that phrasing is very awkward, is kind of noticing the invariant. I also is accepted just in case you want to. Is noticing the invariant in that you always want to keep giving the fewest amount of candy to the lowest ranked, right? So then you kind of process them in that order, and as long as you keep processing them in order, then you can do things to it, which is what I did. So what is the complexity of this, right? Well, this is going to be n log n because of order sorting, and technically of n space, well, because of here, but also Though if you're observant, you notice that we don't actually need this, because we can just add it for this particular problem because we only need to get the total. But there's also a linear space in kind of creating temporary arrays to be sorted. So there's still going to be constant, or sorry, there's going to be a linear space no matter what, at least the way that I did it. Yeah. Am I Gucci? I think, yeah, so n log n time, because of the sorting, you can't really avoid it. I mean, you can always say random stuff like linear sorting, but whatever. That's assuming that we're regular people with our simple comparison-based sorts. Then, it's going to be n log n and linear time, or sorry, linear space because of this thing, but also just this thing. Because as I said, this one you can remove for this particular problem, but here is still going to be constant. Oh, sorry. I keep saying this, linear space. Yeah, and this is greedy sorting. That's what I have for this one. Happy Sunday, everybody. There's only a couple of days left in June, so you made it this far. Give yourself, a pat in the back. Treat yourself a little bit to something. But make sure you finish the last couple, though. That's all I have. Hope y'all have a good Sunday. Have a good rest of the week. And yeah, stay good, stay cool, to good mental health, and I will see you later. Bye bye.